Hello, and welcome to the final core session of Excel Programming for Clinicians with me, Dolotson Callum. In this session, we will put together a lot of the information we have covered, both in the lessons and in the exercises, and together we will build the EGFR calculator that I promised you. So we will look at how to put together a really nice looking interface for our calculator. We will complete the validation drop-down lists to help our users make correct entries. And finally, we will write the Excel VBA programming code for the calculator, complete with message boxes where required and full error handling. Okay, let's start by building the interface. Let's give our calculator a title. And add fields for all the data to do our calculation. I'll need a field for creatinine, another for age, another for gender, and one for race. Okay, let's center this and make it look a bit nicer. Okay, I'm happy with that. Let's make some of these other fields look a bit nicer as well. And we need a field for the units of our creatinine. Okay, let's make a field to hold our results. And let's resize some of these fields to make them look a bit nicer. Let's put an outline around this. And let's hide grid lines. Okay, this is looking good. Now I just need buttons, one to do the calculation and another one to reset all the fields before I do a new calculation. So I could, in the Developer tab, go to Insert and insert a button, but this would look like a plain Excel button. What I'll do instead is I'll insert a shape which I can then use as a button. I'll draw out a shape, give it a shadow effect, and then give it a title. Okay, let's insert another button for resetting. Okay, I'm fairly happy with that. I could spend some time resizing some of these shapes to make them all look a little bit neater, but for now, I think I'm happy with what I've got so far. Next, let's add some validation lists to our calculator. What I mean by that is, I want to limit the units that can be entered here to micromoles per liter or milligrams per deciliter, and I want to limit the entries that can be added for sex to male or female, and I want to limit the entries in the race box to black or other. So in a new tab, I want a list for gender, I want a list for race, and I want a list for units. And in gender, I'm going to allow male or female. In race, I'm going to allow black or other. And in units, I'm going to allow micromoles per liter or milligrams per deciliter. These are my lists. And in my exercise tab, let's limit these entries. Go to data and then data validation. And in the allow box, select lists. And in the source, go to your list and select the 2 entries and click on OK. That now limits entries to only micromoles per liter or milligrams per deciliter. Let's do the same thing for sex. Go to data, data validation, select lists, and in the source box, highlight the column and the rows that you want and click on OK. Finally, for race, we do the same again. We go to data, data validation, list, and in the source box, we select the list. Okay, our calculator is now ready to be programmed. Okay, we're finally ready to write the program code for our calculator. From the Developer tab, click on Visual Basic to open the coding environment. I'll dock mine to the right so you can see both my screens. The first thing we have to do is add a module. Go to Insert, Module. Now we have a module in which we can write our program. We need at least 2 subroutines, one to do the calculation and another one to do the reset. So let's create a subroutine for the calculation. I'll call it EGFR calculator underscore click. So that's one subroutine, and I need another one for reset. I'll call it EGFR reset underscore click. Okay, with those in place, I can now assign macros to my buttons. Notice at the moment, as I hover over these shapes, which I want to use as buttons, I do not get the hand symbol that tells me I can click this. But once I right-click, assign macro, and choose my macro and say OK, now when I hover over them, I get the little hand. Let's do the same for the reset button. Okay, my 2 macros are now assigned to my buttons and I am ready to do the programming. Let's take a look at the standard formula for doing EGFR calculations. EGFR is equal to 186 multiplied by creatinine raised to the power minus 1.154 multiplied by age raised to the power minus 0.203. And then, if this is a female, we have to multiply by 0.742. Also, if the patient is black, we have to multiply by 1.210. So, to calculate EGFR, we multiply 186 by creatinine value raised to the power minus 1.154. We then multiply the whole thing by age raised to the power minus 0.203. And then obviously if female, we multiply by 0.724. And if black, we multiply by 1.210. Okay, the only other thing to note is that if creatinine is in micromoles per liter, then we need to divide by roughly 88.4. Okay, so that's the formula we want to replicate in our program. Let's get started by declaring some variables. We'll need a variable for creatinine, and that will be of type double. And we need a variable for the units of creatinine, and this will be of type string. We need a variable for age. We need another for sex. We need one for race. And finally, we need one for the EGFR. Let's prepare for error handling by putting a label. On error, we want to go to EGFR calculation error. I'll copy that, and towards the end of my sub, I'll put an exit sub. I'll put my label, and now I'm ready to code the error handler. My error handler is going to be based on select case, error number. I don't know yet what the individual cases will be, so I'll code that later. Okay, we're ready to set some variables. Let's set the creatinine. This will be equal to range D5. Value. Okay, my units will be equal to range F5. Later on, I'll be using these units in an if statement. So to make them easy to compare, I'm going to convert it to lowercase. Okay, let's assign age. This will be equal to D7. Let's assign sex. And as I did with units, I'm going to convert this to lowercase. Finally, let's assign race. And as with the others, I'll assign lowercase. Okay, so now all my variables should be initialized. The next step is to check what the values are and make sure that the value that's been entered is valid. So for instance, creatinine can't be 0, because if the creatinine is 0, then my calculations won't work. So I'm going to put an if-then statement. So I'll use an if statement to check the creatinine value. If it's equal to 0, then I want to use a message box to alert the user. Creatinine value must be provided. And I'll give my message box a title. Invalid creatinine. And at this point, because they haven't provided a valid creatinine, I want to exit the subroutine and not continue with the calculations until they provide the creatinine value. Okay, let's check that they've provided units. If units haven't been provided, there'll be an empty string. So again, I want to display a message box. alerting the user that creatinine units must be provided. And as before, I will exit the sub at this point if they haven't provided valid creatinine units. Next, I want to make sure we have a valid age. If they haven't provided a valid age, I want to alert them. Finally, we want to check race. If race hasn't been provided, it will be an empty string. And if they haven't provided race, we'll alert the user. Okay, so far so good. We've initialized all of our values, and we've checked that the user has provided something that's valid. At this point, we're nearly ready to do our calculations. There's just one more check we need to do. It is possible that our user might provide a value for creatinine that is not compatible with the units they've selected. So for instance, if they select milligrams per deciliter, you wouldn't expect the creatinine value provided to be greater than 40. So let's make sure that we do a check for that before we do the calculations. So we say if units is equal to milligrams per deciliter and creatinine greater than 40, then something isn't right. So we alert the user. Creatinine value does not match the unit selected. Okay, let's start the calculations. The first thing we want to do is to check the units, and if the units are in micromoles per liter, then we want to divide by roughly 88.4. So let's grab micromoles per liter, and let's use that in our calculation. We'll say if units equals micromoles per liter, then we want to divide the creatinine by roughly 88.4. In fact, it's 88.41732979666. Okay, so this makes sure our creatinine value is in the right units. So we're ready to do the first step in the calculation. So eGFR is equal to 186 multiplied by creatinine raised to the power minus 1.154 multiplied by age raised to the power minus 0.203. So our creatinine is in the right units. We multiply by 186, having raised creatinine to minus 1.154. We then multiply by age raised to the power minus 0.203. Next step is to check if this is female. And if it is female, we want to multiply by 0.742. So we'll say if sex is equal to female, and I'm writing this in all small letters because I have previously checked I've previously used the lowercase function to convert the entry in the sex field to lowercase. So if female, then I need to multiply EGFR by 0.742. Okay, the next thing I need to take into account is race. And for Black patients, I need to multiply by 1.210. So let's do that here. If race is equal to Black, then EGFR is equal to EGFR multiplied by 0.120. Okay, my EGFR is looking good. Now I want to round it to 2 digits. So I'm using Excel's rounding function. I'm passing in the EGFR and I'm saying I want to round to 2 digits. Let's concatenate on the units. Finally, I can assign EGFR to my result box. Good, so if I've made no errors in my code, I should be okay, but just in case, let's put some error handling for some common errors, such as division by 0, for instance. And let's put a catch-all for anything that we've missed. So let's take a look at what we've done. We are trying to reproduce this formula. EGFR equals 186 multiplied by creatinine, which is divided by roughly 88.4 if the units are micromoles per liter. And then all of that is raised to minus 1.154. The whole thing is then multiplied by age, raised to the power minus 0.203. And then if it's a female, then we reduce the EGFR by multiplying by 0.742. And if the patient is Black, then we increase EGFR by multiplying by 1.210. So that's the formula we're trying to reproduce. We've declared variables to hold all the values. We've prepared for error handling, and we've initialized our values. Having initialized our values, we check that the user has provided valid entries, and if they haven't, we alert them and we exit. And if all entries are valid, we check that the units correlate with the creatinine value entered. And if we're happy with that, then we start our calculations. First thing we do is we calculate creatinine depending on the unit. We then use that to calculate EGFR by multiplying 186 by the creatinine value raised to the power minus 1.154, and we multiply that by age raised to the power 0.203. That gives us the base GFR, and with that base GFR, we check the gender, and if female, we reduce it by multiplying by 0.42. We then check the race, and if the race is Black, we increase EGFR by multiplying by 1.210. We then format our results and present it in our result box. Let's test our calculator. So I've made some basic entries and I click on calculate and we return an EGFR result. Good. So we're very happy with that so far. Now we need to program the reset button, which currently does nothing. Reset is very easy to calculate. We just need to set all of these entries back to 0. So let's do that. Let's select range D5. Set the value property to an empty string. Next, we'll select range F5. Set the value property also to an empty string. Next, we'll do the same for D7. And D9. And D11. And C18. Finally, we'll select cell D5 to allow the user to restart the calculation. Okay, let's test that by clicking the reset button. Okay, that cleared the calculator. So that brings us full circle all the way back to our EGFR calculator and the end of this programming course. I want to thank you so much for sticking with me all the way through these hours of tutorials. I hope you've been able to follow along. I hope you've been able to practice using the practice samples I've uploaded, and I hope you have been able to develop your Excel programming skills. If you've enjoyed this course, I'd really appreciate any comments that you can leave in the comments and the feedback box for this course, and I'd really appreciate it if you could share this with your friends and your colleagues. It's been my privilege and my honor to guide you through this Excel programming journey, and I'll be very, very happy to stay in touch with you if you get in touch with me through my Twitter handle, and I'll be very happy to help you on to continue onwards with your programming journey. Best of luck with everything you do in the future, and please let's stay in touch. Thank you so much for taking this course with me. Goodbye for now.